Hello learners, in this lesson we are going to learn how we can estimate a logistic regression equation and how we can interpret logistic regression equation. With the logistic regression equation, we can model the probability of a manual transmission in a vehicle based on its weight and engine horsepower. We will use logistic regression to compute the odds of having a manual transmission rather than an automatic transmission given the weight and gross horsepower of the automobiles. So, here the dependent variable is transmission type of the automobile model. So, 0 is for automatic transmission type and 1 is for manual transmission type. And the independent variables are weight of automobile engines in pounds and horsepower of the automobile engines. The data I have used in this problem was extracted from 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automobile design and performance for 32 automobiles. So here I am using R programming for finding my estimates of logistic regression equation. So here is the output from R. We know that we have to extract the information from this output. We have to extract the values of B0, B1 and B2 from this output. As we have two explanatory variables in our example, so we have these three parameters to be estimated for this problem. So you can see that here the intercept is 18.86630, which is the value of B0, and for the variable horsepower the value of estimate is 0.03626, which is the value of B1, and for the variable weight of automobile the value of estimate is minus 8.08348, which is the value of V2. We can also obtain the odds ratio for the independent variables. So for the independent variable horsepower, the value of odds ratio is this, and for the variable weight of automobile, the value of odds ratio is this. So as now we have all the estimates of the parameters, we can fit our logistic regression equation. So the estimated logistic regression equation is y hat equals to e to the power 18.87 plus 0.036x1 minus 8.083x2. This is the value of B0, this is the value of B1, and this is the value of B2. And in the denominator, we have 1 plus e to the power 18.87 plus 0.036x1 minus 8.083x2. Now we can interpret the logistic regression model in terms of odds ratio. So we have seen that the odds ratio for the variable x1, which was horsepower, was approximately 1.04. So the interpretation for the variable gross horsepower is the odds of having a manual transmission rather than an automatic transmission increase by 1.04 for every unit increase in gross horsepower. Similarly, the odds of having a manual transmission rather than an automatic transmission are by 0.003 for every 1000 pounds increase in car weight. So previously I have told there is an interesting relationship between odds ratio and the regression coefficients. So this is the relationship where odds ratio equals to e to the power beta j, where j belongs to 1 to p, where p is the number of explanatory variables. So in our problem we have two explanatory variables, and we also know the values of b1 and b2. So from the values of B1 and B2, using this relationship, we can also calculate odds ratio. So as we know that B1 equals to 0.03626, so the odds ratio for the variable horsepower will be e to the power 0.03626, which is approximately 1.0367. And as B2 equals to minus 8.08348, the odds ratio will be e to the power minus 8.08348, which is approximately equal to 0.003. So from the values of the regression parameters, we can easily calculate the odds ratio.